Hi, and welcome back to our APES flipped classroom. We're continuing our discussions of Unit 3, and today we're talking about survivorship curves. So when we talk about a survivorship curve, we are talking about the cohort of a particular age, cohort, a group of same-aged individuals, and how many of them survive, or what percentage of them survive in a population from their birth to their death. And we generally categorize these into three types. So the faster the line that we see here drops off, the quicker the individuals in the population are dying. So if we see a line like this one, it means that many of the individuals in that population die early. We see a line like this one, it tells us that many of those individuals survive into old age. So the slower dropping line is the longer average lifespan, and the fewer of them that die early on. And here in the middle, we have type 2, and that tells us that the number of individuals, or the percentage of individuals that die at each stage of the lifespan, is pretty level. So let's take a quick look. So type 1 is generally archaea-selected organisms. They have high survivorship early in their life because they have intense parental care. They also have high survivorship in midlife because they are generally larger animals. They're better able to defend themselves. And then late in life, that's when most of them die. And so that would be most mammals, particularly your larger mammals. And so that's our type 1. And the type 1 is going to be that curve. Let's go back to the picture for just a second. So type 1, you can see very few of them die off early on, very few die off as we go along. And then late in life, as we reach old age, many of them begin to die off. Now, this age line at the bottom that we see for type 1, type 2, and type 3, this is frequently written as percentage of lifespan rather than actual age, because we really can't compare, for example, a dandelion to a whale, and this seems to be a fin whale, in terms of their actual age, but just in terms of their lifespan. So rather than thinking of this as age necessarily, think of it as percentage of average lifespan. Okay, so let's talk about our type 3, and then we'll come back to type 2. So type 3 tend to be the R-selected organisms. They have very high mortality early in their life because they have little or no parental care. So we can think of sea turtles as an example of this. A sea turtle comes ashore, lays hundreds of eggs. Of those hundreds of eggs, very few of those hatchlings even make it into the water. Those that do make it into the water frequently don't make it past the first couple of weeks because they are preyed on by other organisms. So very few make it to midlife. And then in midlife, there's a steady, slow decline in survivorship, but very few of these organisms actually make it to adulthood, make it to reproductive maturity. And then there's that slow decline in survivorship in old age. So again, if we go back to our image, we can see that very many of them die off before ever reaching maturity. And then there's this slow, steady decline, and very few make it all the way to the end of their lifespan. Okay, so type 2, those ones in between the R-selected organisms and the K-selected organisms, they have a pretty constant decline in survivorship no matter what their age is. And so birds are frequently used as an example of type 2 because if we look at birds, here we have squirrels on our picture. In a nest, you might have 3/4 of the eggs hatch. And of those hatchlings, 2 out of the 3 might become fledglings. And then the fledglings, 1 might survive to adulthood. So we have a relatively constant amount of death throughout the lifespan. And so that's a type 2 organism. Type 1s and type 3s are a lot easier to come up with, but remember that it's all about how many of them survive initially. So Do they survive through infancy and childhood and mid-age and die as old in old age? That's a type 1. Type 3, many die early on and never reach adulthood or sexual maturity. Okay, so here's your practice for this objective. I'd like you to describe the trend in survivorship shown in this graph. And I want you to justify which type of survivorship curve these data represent. Record this in your notebook and we'll discuss it in class. As always, if you have any questions, let me know. I look forward to seeing you soon.